So first, I have to start with the F5. As said, I will disable all the signatures. So go ahead and do that right here. And then apply. All right, now our signatures are disabled. So we're going to start on DVWA and the SQL injection. This is the one that we did attack before. So we'll take note of our URI. And we'll go over to our F5. And come over to URLs. Now, in a lot of situations, you can create global parameters. And in this case, we will do that. But just for the sake of kind of building a WAF policy structure, it's not always required, but sometimes it gives some context on what you're designing and helps you have something to reference back to remember what the web application actually looks like. And sometimes eventually you may be creating these URLs down the road. Do I always do this? No. It just depends on the situation. So in this case, show and tell, kind of go a little extra, a little further than I normally would. But then again, as said, there are plenty of situations where I will automatically do this. So because the URL very specifically was DVWA vulnerability SQLi, I'm going to go ahead and create a wildcard because in this case, I know DVWA is actually the created path that we designed versus it being a default path, which is vulnerabilities and SQLi. So this case, if anybody changes the root structure, this policy will always apply. So we're going to run with that and we'll wildcard it. And does not include slashes. And we'll go ahead and create that. Next, we'll go and create the parameter. Now, the two parameters. Now, if you reference the logs, you'll actually find these within there. I'm not going to reference them for the sake of time in this case, and we've previously covered it. So go watch the other video. All right, let's go ahead and create some parameters. Got a handy little plus button, so we'll start with that. And I'm going to call it ID. Now, ID, in this case, that's what we see here. Now, let's go ahead and take into consideration what we're looking for here. This is a user ID. Now, clearly, this implies there is no limitation, or there is, and it's just really long. So, nonetheless, typical user IDs are 8 characters, sometimes 16, 32, 128. They fall within those, standard computer byte ranges. So in our case, we have to consider that. And a user ID, we'll consider an email address because email address would be the lengthiest user ID that you typically see. So we'll just kind of look at it from that perspective. Jim Bob Jones at yahoo.com. So with this, we'll go and submit it. Now, with our fancy developer tools, we'll go ahead and take a look down here, and we can see there is actually no request payload. We can also note that it's a GET under our method, hence no payload. It just happened to be default there. It's where I was last at. Moving on. The URL, we can see, actually includes the parameters directly rather than within a post body. Okay, no big deal. WAF doesn't really care. Treats them equally the same, depending on which WAF you're talking about. Could be different. So in our case, we're going to go and protect the ID and the submit parameters. And as we can see here, both are used. So we'll go ahead and roll with that, and we'll keep the ID. So we'll pretend the ID has a maximum length of 128 characters. Kind of fits within the realm of email addresses. Yes, technically it can be longer, but I've seen plenty of web apps actually put limitations to 128 characters, including many authentication systems. 128 characters, just kind of like a de facto limit that's already been predefined in many systems. Kind of like 32 characters is a common length for password limitation. Not as true so much anymore, but moving on. So in our case, explicit parameter ID, and we're not going to do staging because we know we know what we're doing here. Now, empty value. In our case, this one can be dangerous just because if you refresh the page, it's very possible that the ID would be blank, but still may be present and called. So because we do not want to impact our user negatively for a very potential normal situation like refreshing the page or expired timeout, we will go ahead and leave this enabled. Now, for repeated occurrences, this is a singular function in this case due to this form because it's a single ID lookup. But because we are using a global parameter, it is potential that this parameter could be used elsewhere, such as a multi-ID lookup form. So we have two choices. We can either go very specific for this URI, as we created earlier, or we could, again, go for the global aspect, which we will. And then with that in mind and the genericness of ID and how it could be used elsewhere, particularly in PHP forms where ID references kind of like a certain column in a database versus an ID as a user ID, numerical versus words. These are things to consider. But for the moment, what we see, we know it's a user ID in the standard context. So we'll keep that in mind. And because we've reviewed the rest of the web app in this case, we know there is no multi-ID lookup. So we will actually not allow repeating occurrences for the ID parameter. Now, moving on to the meta characters, we'll go ahead and enable the checksum here. And this is where the real power comes into play of what you can do with the WAF, and a big reason on why we can get away with not enabling the signatures and still provide 0-day or at least close to type mitigation in many instances. Not all. There are plenty of situations where you pretty much need signatures or alternative solutions, such as DDoS or account authentication verification. But we're just going with the basic WAF stuff for today. So moving on here. For a user ID, a space is actually not appropriate, nor is exclamation, hash symbol, no. And then we'll go down and these ones, not acceptable either. Now with asterisk is a little unique because in some authentication systems, there's been an attempt to hide PII data, and I mean, it's kind of appropriate, but it's really kind of a nightmare for security analytics when you hide the user ID, mask it. So you have a user ID with, like Jim Bob Jones, and all you see is Jim, asterisk, 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 and they don't even match up to the full length. It's just, an arbitrary set number of fixed number of asterisks. It makes it very difficult to do security analytics, and it gains you very little. However, in some efforts to defeat PII being logged, some developers have gone through and provided this solution, if you will. And it's a poor solution. In fact, it actually really achieves nothing. The auditor really probably wouldn't even care. You certainly won't get any bonus points for it. Nonetheless, it has been seen. So, taken into consideration, we may need to add this, but in the review of this web app that we've done, we actually know that we don't. So we'll go ahead and move this to the disallow area. Now for dashes, well, user ID, I mean, that's kind of pretty typical. So we'll go ahead and keep that. Slashes and colon, no. And then question mark, certainly not. At, well, could be an email address, so very potential. We'll keep that. And then caret, absolutely not. Never used, nor is the tilde. And we'll just go ahead and add in the comma. We will keep the plus because I have seen some situations where the plus symbol is actually used, but not always. So we're not totally sure because we don't know the full back end aspect of the system that we have here. And who knows, maybe normally it actually uses all user IDs like email addresses. But then in some rare instances with a very specific account, you'd actually have to use a plus. So we'll go ahead and keep that in mind. And sure, we'll actually add that one. And with that said, we can go ahead and create our parameter. Give it a quick review. Looks good. All right. And one thing we'll actually cover real fast here too. We'll take note that I did not select attack signatures. We'll enable that later, but for the moment, it's not part of the intent because we want to demonstrate the ability to mitigate these without signatures and then add the additional awesome sauce of signatures to catch all the other amazing thing or all the other really bad stuff and really just provide a lot more detail for the things that we do detect and mitigate with these controls already. So, I mean, essentially, the more evidence you have for any given case, the more weight you have, and certainly the more viable your conclusion would be. So, with that said, we'll go ahead and go back. Now, coming over here, we have our ID parameter that we had talked about and just created. We also have the submit parameter to work on. Now, keep in mind, we do see a capital S here. And for the value, we see submit with a hash symbol in the actual URL. Now, we see down here, there is no hash symbol. And then coming over here, there is no hash symbol. So this creates a bit of confusion. In our case, the web browser is doing some decoding for us to make it more pertified and easily readable, but the WAF doesn't see it that way. The WAF sees exactly what is sent. There's no assumptions to be made with the WAF. There's only assumptions to be made how you design and configure the WAF. So again, ones and zeros. And that's what we like because consistency. That's very, very important. So we'll come back over here and create our second parameter for submit. Now, it's important to note that this policy is case insensitive. So even though the parameter in itself has a capital S, it doesn't matter because the policy is case insensitive. So when I type it as a capital S, when I save it, it will be lowercased. Now, this is very specific to the ASM F5. So other WAFs do handle this differently, and different elements within the WAF can handle case sensitivity differently, even within the F5. Despite case insensitive, globally, it's not necessarily entirely true. We'll cover that a little bit later, but nonetheless, we'll go and create it for demonstration purposes with capital S, because it doesn't hurt you. Now, we're not going to do perform staging. And in this case, as we see with the web app, it has the value of submit. So in other words, it's a word. And also a phrase in some of the other aspects of the site that we come across. And it's not uncommon for it to be a phrase. So essentially a word or a phrase, but it's limited. It's not like a comment field or a user ID. So there's some context that we can kind of predictively assume here and roll with. But the key thing is it's a singular function, so it's not going to be repetitive. So we will not allow the repeat. But because of the ability to refresh the page and potentially have a parameter called but not have a value called, that would be appropriate. So we'll go ahead and allow the empty value in this case as well. Now, for the length, to the word and phrase consideration, and for application development, they tend to like the approach of simple. You don't want to get too complex in your button naming convention, unless, of course, you have a really complex naming convention. In this case, we don't really have one. So it's very likely to assume, and based upon our evaluation, we do know that it's very limited scope. So we'll go and give some flexibility for future design, and we'll go and give the length of 16. Again, my little 8-bit values that I kind of like, but at least gives us a degree of control for length, because the button value would not be 2,000 characters long. So we do ideally should imply some kind of limitation. And we know it's not going to be 128 characters, certainly not in our situation, but we'll go ahead and roll with 16. Just sounds good. I could do 8 if I really wanted to, but in this case, it's a little too stringent, and 16 would be pretty adequate control, especially given the fact that we're going to now enable the meta character controls. So we'll go ahead and do that. Now, to the word or phrase sense, more so phrase, space is very potential to be used, so we'll go ahead and allow that. Now, it's not a statement or a statement of excitement, so we'll go ahead and disallow the exclamation. Now, we did see the hash symbol, so we'll definitely go ahead and keep that. Now, these characters, definitely not appropriate. They're not used in this context. We'll go ahead and keep the dash just in case, but these other ones likely will never be used, and certainly not in this case. The question mark and the @ symbol, definitely not going to be used. And same thing with caret and the tilde. And we'll come down here and add the comma in, just, why not? And there we go. So we have our characters pretty well laid out. We'll come through here and do the disallow, tab D, get that rhythm flowing. All right. And as said before, we're not going to do attack signatures here. We'll take care of that at a later point in time. We're just proving a point. And I do believe we can say that this is adequately set up. Data type 16. So we'll go ahead and create our parameter here now. And there we go. And that effectively does protect both of the parameters that are involved here. Now, let's go ahead and take a look at SQL injection blind. And we'll go ahead and test that one. No limitation. So we'll do Jim Bob. Submit that. Come down here. We've got a method of get, just like the previous request under SQL injection, and actually 404. So not found. User ID missing from the database. All right, cool. Makes sense. That's actually a bad thing, because that does imply that the user ID does not exist. So you have the ability to run through a list of user IDs and figure out which ones do exist. But advanced topics, not today. So to the point of what we're going for, we already have the ID protected, and within the same context in which we wish to protect for the other site, the same context applies here as well. Same thing for submit. Singular form, no repetition, no multiple ID lookups, no multiple buttons. So we can go ahead and kind of roll with this, and because of the protection that we've already provided for the other page, we're pretty much done here. However, we'll go ahead and add in our URL just for the sake of our policy structure. Wildcard it, no staging, and then match there. Just for the sake of explanation, you may wonder why I have not deselected this, because when I do enable attack signatures, this will actually take effect. However, for the current moment in time, because the overall global setting is disabled, these actually do not apply. So can I go ahead and create the parameters for the rest of the show with that enabled? Yes, I can. But to emphasize the fact that the signatures are disabled, I will keep them disabled very specifically on the parameters for the rest of the presentation. All right, so come back over here, and now we have this created. Now, as discussed, both of these cover both the SQL injection and the blind URLs and the lessons within DVWA for the protection, and they provide pretty full-on protection. The key reason being the characters that we do not allow. So most script-based attacks, SQL injection, cross-site scripting, command injection, they all tend to require special characters such as, the percent, the ticks, quotes, and the most important ones, or the most common ones, and certainly the most dangerous ones, would be the greater than or less than symbols. And often I just refer to them as script tags. So very relevant to HTML, JavaScript, etc., cross-site scripting. So by taking these out, this mitigates most of all your attacks kind of automatically. And with the additional characters, perceivably, most of these SQL injection attacks really could never succeed because they do require the use of these additional characters. Now, dash, we did allow that. So some of those attacks obviously very well could succeed to some extent, but by negating all the other functions, that pretty much mitigates that possibility as well. Now, there's the story of stored procedures, but that's a little more deeper, and that's not something that you can directly protect within the WAF itself, because for the most part, a stored procedure would be something that already is defined and essentially is considered a legitimate request. It's not something that we're looking for in the WAF sense. But if we do know there is vulnerabilities around it through, say, your application vulnerability discovery team, then from the WAF perspective, we can certainly provide additional layers of protection around that, potentially. Not necessarily always, but there's always opportunity for creative solutions. Now, we'll also take note here that none of these are set to deny or to disallow. Part of that intent is to demonstrate we were doing really, really good. We had a good thing going there, and we got them all set up. We were explaining things. Oops, we actually totally missed something, and we would have actually allowed all these. So essentially, we would have not achieved our goal. So let's fix that. Get our flow going. Tab D. And one more. And we'll go ahead and update that. And that pretty much concludes what we're going to do for the SQL injection lessons within DVWA to provide that 0-day complete to close mitigation. And we'll go ahead and move on next to the XSS DOM. The key reason we're not going to jump into the actual attack right now is just because we're going to focus on the WAF configuration first. And then once I'm complete with building out everything within the WAF, then we'll actually move on to replaying the attacks and see how well we did. So moving on, we'll go ahead and get on to XSS DOM.